Alright, today we are going to multiply polynomials, and the first ones we're going to look at are monomials. Remember, that is one term, so we're going to multiply one term by one term. And we've done this in some of the IXLs, I think. If you did the IXLs, I should restate that. So 5x squared times 4x cubed. With this one, we simply multiply our whole numbers, so we have 5 times 4, and then we use the property for exponents where that tells us when we are multiplying exponents, we actually add them. So we end up, that should be all the way down there, we actually end up with 5 times 4, which is 20, x, and then 2 plus 3, which is 5. Next problem we're going to look at is negative 3 x cubed y squared times 4 xy to the fifth. So we're going to look at our whole numbers first, negative 3 times 4, and then we're going to take each one of our bases and combine it with the other one. So we have a cubed on the first x, and the second x doesn't have an exponent, so we assume it's 1. And then we look at our y. Our first y is squared, our second y is to the fifth power. And then we take negative 3 times 4 and get negative 12. X, 3 plus 1 is 4, and then with our y, 2 plus 5 is 7. We have one more. It's a little bit longer. It's 1/2 a cubed b times a squared c squared times 6b squared. So this has 3 terms that we're multiplying by, but you do the same thing. So we take our whole numbers, or our constants, half is a constant, so we're going to bring that down, times 6. The second term doesn't have a constant. And we're going to combine our a's. So we have a, and we have a cubed and a squared. And then we're going to combine our b's, and we have b times b squared. And then our c squared. And the middle term is all by itself. So half of 6 is 3. When we combine our a's, we get 5. When we combine our b's, we get 3. When we combine our c's, well, we have nothing to combine. And I forgot that up top, I was writing these like this. So if you're confused to why you switched, you can switch those back to 1 plus 2. I followed the book for that example. Anyways, now we're going to multiply a polynomial by a monomial. So, polynomial. So the first one we have is 5 times 2x squared plus x plus 4. And for these, all we're going to do is distribute. So we take 5 times 2x squared, bring down our plus, 5 times x, bring down our plus sign, 5 times 4. And then we have 5 times 2, which is 10x squared, plus 5 times x, which is 5x, plus 20. And that's no common like term, so we leave it like that. Next one is 2x squared y times 3x minus y. So same thing, we're going to distribute 2x squared y times 3x, bring down our minus sign, and 2x squared y times y, and then we're going to multiply our constants, so 2 times 3. When we combine our x's, we have 2 here and 1 here, so we add them and we get 3, and our y has nothing to combine with, minus 2. Our x doesn't have another base of x to combine, but our y has a 1 here and a 1 here, so it gives us y squared. 4a times a squared b plus 2b squared. So we take our outside term times our first term plus our outside term times our second term. We multiply our constants, in this case it's 4 times 1. A, this has an exponent of 1, so we have 1 plus 2, which is 3, and then b, there's only one b for a base. Plus, multiply 4 times 2 and get 8. You have nothing to add to your base of A and nothing to add to your base of B. So, okay, so now we're going to multiply binomials. And I'm going to teach you 2 different ways how to do these. So, we have a method called the FOIL method, and the F is for the first term in each set of parentheses. The O is for the outside term in each set of parentheses. That would be the first and last. The I is for inside term. And the L is for the last term in each set. So I'll show you what these look like. The first term, if you had 2 sets, would be the term here and here. The outside term would be the term here and here because they're on the outer. The inside term would be here and here because they're inside, and then the last term is here and here. Okay, so this is called the FOIL method. Some people find this easier, some people find using distributive property easier, so we're going to learn both because I don't mind either one. X plus 2 times x minus 5. So, we're going to look at our first terms. So we have x times x. Then we're going to look at our outside terms. So we have plus x times negative 5, because there's a negative in front of the 5. And we're going to look at our inside terms, plus 2 times x. And then we're going to, I should not have lined those, inside. And then we're going to look at our last terms, which is plus 2 times negative 5. And then we're going to go through and multiply. X times x is x squared. X times negative 5 is negative 5x. 2 times x is positive 2x. And 2 times negative 5 is negative 10. When you do the FOIL method, these 2 terms should be common, and you should be able to combine them and get x squared minus 3x minus 10. So let's look at one more doing the FOIL method. We have x plus 5 squared, and what that means is x plus 5 times x plus 5. So we're going to look at our first terms. So we have x times x. Then we're going to look at our outside terms. Outside terms plus x times 5, our inside terms, plus 5 times x, and then our last terms, plus 5 times 5. And then we're going to multiply x times x is x squared. X times 5 is 5x, we always lead with our constant, plus 5 times x, which is 5x, plus 5 times 5, which is 25. Look at these two middle terms. They are like terms, so we can add them to get 10x plus 25. Now, if we want to do distributive property with those, we can. Let's write another one down. 3a squared minus b times a squared minus 2b. And to do the distributed property, you multiply the first term by the first and the second, and then you multiply the second term by the first and the second. And so when we write that out, we would have 3a squared times a squared plus 3a squared times negative 2b, and we would look at the second, minus, there's a minus sign in front of the b, times a squared minus b times negative 2b. So when we go through and we multiply each individual term, and we get 3, and when we combine our base, we get 4, plus, well, that's going to be a negative, so we don't need to write a negative. Oops. Negative 3 times 2 is 6, a squared b, because there's no basis to combine, minus a squared b. And then on this last one, this is a negative 1 actually. We can look at this as a negative 1 times a negative 2, which gives us positive 2b squared. And then still look at this magic trick. These two middle terms are alike, so we get 3a to the 4th minus 7a squared b plus 2b squared. So, in my world, they're the same amount of work, but some people just like the first one because it tells them exactly what to multiply when. However, it is important to know this method here when you are multiplying a binomial by a trinomial. So the next thing is just multiplying polynomials. And this is where it's good to know the distributive property, because we're going to multiply a binomial, which is 2 terms, by a trinomial, which is 3 terms. And if you'll notice, with 3 terms, you don't have an inside-outside last with the first term. The only time first, outside, inside, last works is when you're multiplying a binomial by a binomial. So we have to do the distributive property with this. We take the x times x squared, the x times negative 5x, and the x times positive 4, and then we go through and we take the 2 times x squared times negative 5x times 4. So we have x times x squared plus x times negative 5x plus x times 4, and then we change degree, plus, so we've multiplied our x by every term in the second and the trinomial. Now we multiply our 2 from the binomial by every term in the trinomial. So times x squared plus 2 times negative 5x plus 2 times 4. Then we go through and multiply. X times x squared, we assume there's a 1 there, so we get x cubed minus 5x squared plus 4x. plus 2x squared minus 10x plus 8. And on this one, we have to go through and combine like terms. So we gotta look. We have a negative 5x squared and a positive 2x squared. And we have a 4x and a negative 10x. They're not gonna just be right in the middle with these. So x cubed is by itself. Negative 5x squared and positive 2x squared both have a yellow line under them, so it's negative 3x squared. 4x and negative 10x both have a red line, so we can combine them to get negative 6x, and then plus 8 goes at the end. Okay, next problem. 3x minus 4 times negative 2x cubed plus 5x minus 6. So we're going to distribute. We're going to take first term times the first term, second term, and third term. And we're going to take the second term of the binomial times the first, second, and third of the trinomial. So we have 3x times negative 2x cubed plus 3x times 5x plus 3x times negative 6. Now we're going to take the second term in the binomial, negative 4 times negative 2x cubed minus 4 times 5x minus 4 times negative 6. So we get negative 6x to the fourth plus 15x squared minus 18x plus 8x cubed minus 20x plus 24. And all I did was multiply each one of those terms together. And we go look for common terms. We have negative 18x and negative 20x there. And I think that's all we have in common. So we're going to write those terms down in order of the degree they have. So 4 is the highest degree, so we have negative x fourth. And then we have a third degree here, so plus 8x to the third. We have a second degree here, so plus 15x squared. And our common terms have a degree of 1, so they will come next. Negative 18 minus 20 is negative 38x. And then this has a 0 degree, so it goes last. Make sure we got the right answer. That was a long answer. We did. The next problem, we're going to combine the FOIL method and the distributive property. So on this one, we have x minus 2 cubed, which means we're going to see x minus 2 3 stinking times. So what I like to do with these is I like to FOIL these first two, and then once I've done that, I will have a trinomial, and I will take that trinomial and I will distribute with the third x minus 2. So if we look at our first, we have x times x. If we look at our outside, we have negative 2, let's put the x first, plus x times negative 2. I was just going to write the answer. Then our inside, negative 2 times x, and then our last, negative 2 times a negative 2. So then we can go through and we can multiply and get x squared minus 2x minus 2x plus 4. Look at this, our middle terms are alike, so we get x squared minus 4x plus 4. So that gives us what x minus 2 times x minus 2 is, but we have this third x minus 2. So we need to then rewrite this as x minus 2, we put our binomial first, times our trinomial. We got x squared minus 4x plus 4. So, and we're going to distribute. We're going to take x times each term in the trinomial, x squared, plus x times negative 4x plus x times 4, and then we're going to take our negative 2 times every term in the trinomial, minus 2 times negative 4x minus 2 times 4, and then we're going to multiply, and on this we're going to combine our x's to get x cubed, minus 4 are x's, there are 2 of them, plus 4x minus 2x squared plus 8x minus 8. And then we're going to go through and see if we have any like terms. It looks like we might have a few. Negative 4x squared, negative 2x squared, and 4x and 8x. So we're going to go through and combine and write them in the order of degree. So we have x cubed, and then our 4x squared and our 2x squared have black lines underneath them, so they are in common. And then our 4x and our 8x have green lines, so when we combine those we get plus 12x, and then our negative 8. So those are written in the order of degree as well. Okay, if you understand those two ways, you need to understand those two ways for when you're multiplying a binomial by a trinomial. I have one other way you can do, and if you're a visual learner, this might be helpful for you. We have 2x plus 3. And then x squared minus 6x plus 5. So that's the problem. And we know we can go through, and this works for binomials and trinomials. We know we can go through and do the distributive property. However, we can set this up in a table, and we can take our binomial and we can write each term horizontally here. And then we can take our trinomial and write each term, I'm sorry, that's vertical, I get confused all the time, and write our trinomial horizontally here. Okay, and what we're going to do is we're going to put a little table here. Since we have 2 vertical, we're going to have 2 rows, and since we have 3, we're going to have 3 columns here. And this is going to look pretty much just like a multiplication table. So you have 2x times x squared, which gives you 2x cubed. For this box here, you're going to take 3 times x squared, so you get 3x squared. For this box, you're going to do 2x times negative 6x, so negative 12x. For this box, you're going to look to the left, and we have 3 and up and negative 6, and you get negative 18x. For this box, you look to the left for your term 2x, up for your term 5, and you get 10x. And for this box, you're going to look to your left and get 3, and up and get 5, multiply and get 15. I feel like I messed something up along the way. That should be a squared, my bad. So, then all you do is, this is a weird addition type of thing, you add only in the table diagonally, and if you look diagonally you have like terms. So 2x cubed, you can't go diagonally, so you have 2x cubed. For negative 12x squared, you go diagonally and you see plus 3x squared, which is negative 9x squared. And for 10x, you go diagonally and you have negative 18, so you have negative 8x. And for 15, you can't go diagonally, so you have plus 15. That also works for binomials. When you're multiplying a binomial times a binomial, and it works a little bit better for those. You have s plus 3 times s minus 2. This first term, you're going to write vertically an s and a 3. And the second term, you're going to write horizontally And then you're just going to have a 2 by 2 table. So you have s times s, which is s squared, 3 times s, which is 3s, and then you're going to do s times negative 2, which is negative 2s, and 3 times negative 2, which is negative 6. And then you look diagonally, s squared, you can't go diagonally, so you have s squared. Diagonally here, negative 2 plus 3 is plus 1s or plus s, and negative 6 you can't go diagonally. And the reason it works better in my mind for binomials is because you only have to go diagonally once. So you don't have to use those, but if you want to, you can. And if you actually watched this whole thing, because I know some of you did not, because it's 26 minutes. My birthday's on Sunday. I will be 31, so you can write 31 at the top of your paper for extra credit. And then if you did watch the whole thing, don't tell other people about this extra credit because they didn't watch it.